Hello, this is an introductory video on how to integrate by parts. Now, integrating by parts essentially is taking use of the following formula. Integral of u with respect to v is equal to u v minus the integral of v du. Now, it's not as scary as it might look. What we're essentially saying is that we're looking at the original integral. This is the question, and we are picking a part of it to be u, and we are also picking a part of it to be dv, and then we simply rewrite this like this. So we just take that u from the original equation and put it here. We take what is dv, we integrate it, and we get v. And then we simply have minus the integral of v times by u differentiated. Now, the only tricky part is knowing what to choose to be u and what to choose to be dv. So I'll hopefully be able to explain that to you in the following example. Here's a question I wrote earlier. The integral of 2x times by e to the minus 2x dx. Now, and I'll quickly put a box around this just so we know that that is the formula we're using. So the first thing to do is to consider what is u and what's dv. Now, obviously v is going to be integrated and u is going to be differentiated. Now, I'll let you in on a little secret. The trick is to choose to be u that which is differentiating into a more simple term. So which one of these differentiates into a more simple term? This differentiates into minus 2e to the minus 2x, I believe, but this 2x simply differentiates to 2, and as you know, coefficient values such as 2 can be taken outside of the integral. So looking ahead, we're probably going to be labeling 2x as u, and e to the minus 2x as dv. Now, with exponentials, it might look scary, but they're very simple to integrate. We simply take the differential of this bit up here and stick it underneath. So let's get on to the workings of the question. So if we have u equal to 2x, we're going to want to differentiate u with respect to x. So du dx equals 2. And looking at the equation that we want to end up with, we have a du. So we're going to want to get du on its own. So it'll be du equals 2 dx if we multiply throughout by dx. I often simply look at it as just shifting the dx up here. Now, the other work that we have to do is regarding our dv term, which we chose to be e to the minus 2x. Now, if we want to integrate dv, we end up with v equals minus e to the minus 2x over 2. And that comes about simply by integrating this because it's exponential. I'll just clarify what we did. V is, of course, equal to e to the minus 2x dx integrated, which gives that. Okay, now we have all of the basics here that we need to rewrite this as this. So now we're going to rewrite it uv. Now we have u equals 2x, and we have v, if I can move my paper up, v is equal to minus e to the minus 2x over 2. So uv what I'll do is there we are. I'll write the original question on the left so you can see the workings. uv, so 2x times by minus e to the minus 2x over 2, so I'm going to put the minus in front. Now note that the 2's cancel. Okay, now the next part of this equation is minus the integral of v with respect to u. Minus the integral of v, which is here. Now I have a negative sign here and another one here, so if I take that one from here and put it there, we have plus. So we have integral of e to the minus 2x over 2. Now I can take the 2 outside of this as well. What we need now is the du term. And we calculated the du term earlier to be 2 dx. So I rewrite that in there. Now notice, if I'd kept the half in here, it would have cancelled out nicely. So I can go ahead and cancel it out anyway, but I maybe should have left it in, but you know, no difference. So now we can come to solving the equation. So I rewrite this, minus x e to the minus 2x plus the integral of e to the minus 2 over x, which we know is minus e to the minus 2x over 2 plus the constant. Apologies for the camera problems that I experienced during the shooting of that video, but I hope it was able to help you. Please feel free to click subscribe and like, because I'll be doing videos that people ask for, and I'll help as many people as I can. Here again is the equation if you want to copy it down. Thank you for watching.